Hi, my name is Basir. In this video, we will work out exercise 12.2 problems. The first question says a TV tower stands vertically on the side of a road. Okay, so I'll go ahead and draw a diagram here. Let us say this is our road and this is a TV tower which is standing on the side of a road. From a point on the other side directly opposite to the tower, the angle of elevation of the top of the tower is 60 degree. Okay, so I'll go ahead and do this. From this point, which is on the other side of the road, this is our road, this one is our road, and this is our TV tower. Okay, so now from this side of the road, someone is looking at the top of the tower and the angle of elevation he get is 60 degree. Now from another point 10 meter away from this point, on the line joining this point to the foot of the tower, the angle of elevation of the top of the tower is 30 degree. So it's saying that there is another point here which is about 10 meters away from the previous point. So from this point, this guy again looks at the top of the tower and the angle of elevation that he now gets is 30 degree. Find the height of the tower and the width of the road. So I'll have to find out the height of the tower and the width of the road, this width. Let me name these points as A, B, C, D. Okay, so we now see that we have two right angle triangles, right? The smaller one BCD and then the bigger one ACD. So we have two right angle triangles. I have to find out the height of the TV tower. I don't know the height of the TV tower. Let me just represent it as X. And then we also need to find out the width of the road. Let us just denote it as X for now. Let us apply tan theta to the smaller triangle with the angle 60 degree. Tan theta is opposite side by adjacent side, right? So what is the opposite side here? For 60 degree, the opposite side is H and the adjacent side is X. Tan 60 is root 3. Root 3 is equal to H by X. H is equal to root 3 X. Okay, now I'll do the same thing. I'll apply tan theta to the triangle that has the angle as 30 degrees. So for this triangle, the bigger triangle ADC, tan theta is again opposite side by adjacent side. Tan 30 is 1 by root 3. What is the opposite side for this angle? For 30 degree angle, again same CD, which means H is the opposite side. I have represented the height of the tower with the letter H. I'll have to find out the value of H. By adjacent, for this bigger rectangle, the adjacent side is AC. So AC is this, from here to here it is 10 meters and from here to here it is X. So AC is 10 plus X, total it is 10 plus X, right? I'll just cross multiply again, or else I'll just multiply 10 plus X on to the right, to the left hand side. 10 plus X into 1 will be 10 plus X. From 1 and 2, from 1 and 2, LHS is equal, so I can equate the right hand side. 10 plus X by root 3 should be equal to root 3x, right? 10 plus X is equal to root 3x. Root 3 is dividing, so root 3 will multiply here. 10 plus X is equal to root 3 into root 3 is what? Root 9. Root 9 is 3, so I'm writing 3. I'll take X one side and then I'll take the number on the other side. 2x is equal to 10. X is equal to 10 by 2, which means the value of X is 5. So the width of the road is 5 meters, right? Now we have to find out the height of the tower. Okay, from equation 1 we have height of the tower as root 3x from this equation, from equation 1. Now that I know the value of X, as 5. I'll substitute the value of x as 5 here. So h is 5 into root 3 is 5 root 3 meters. So height of the TV tower is 5 root 3 meters. Let us go ahead and solve the second problem here. So you see, this is pretty simple. All you have to do is, if you can comprehend the question and draw a relevant diagram for it, half of the job is done, right? Let's see how to draw a relevant diagram for this one, for the second question. It says a 1.5 meter tall boy is looking at the top of a temple which is 30 meter in height from a point at a certain distance. So it is saying that there is a boy whose height is 1.5 meters. Let's say this is the boy, his height is 1.5 meters. He's looking at the top of a temple. Let's say this is the temple. This guy is looking at the top of a temple. The angle of elevation is, the height of the temple is given as 30 meters. So the total height of the temple, this temple, as I told you, for problem solving we take temple or boy, everything as linear, as a straight line, right? So I'll represent the boy as AB. The boy's height is 1.5 meters, and then I'm representing the temple as CD. CD, the height of the temple is 30 meters. Let's say this is the ground here. Now this boy, the second sentence, let us read the second sentence. It says the angle of elevation from his eye to the top of the crown of the temple increases from 30 degree to 60 degree as he walks towards the temple. So previously the angle of elevation was 30 degree. Now this boy, he walked certain distance. Let's say he walked from here to here. From this point again he is looking at the top of the temple. Now the angle of elevation is 60 degrees. We'll have to find out what distance he walked towards the temple. So we'll have to find out this distance, the distance that he walked towards the temple, right? So the question is pretty simple. It says that the height of the boy is 1.5 meter, the height of the temple is 30 meters. This boy is looking at the top of the temple and the angle of elevation that he gets is 30 degrees. He walks a certain distance. Let's say he walked a distance of x meters, and now when he's looking at, now from this point, when he's looking at the top of the temple, the angle of elevation is 60 degrees. Now we have to find out how much distance he walked from point B to point E. So we have to find out the value of this x. I don't know the value of EF, so I'm representing that as y. Also this figure here, A, B, F, C, this forms a rectangle, and we know that in a rectangle opposite sides are equal. So if this AB is 1.5 meters, then FC should also be 1.5 meters. So the total distance from C to D is 30 meters. If I remove this 1.5 from 30, this distance DF should be 28.5, right? 30 minus 1.5 is 28.5. So now again we have two right angle triangles. The smaller one is EFD and then the bigger one is BFD, right? So we'll apply tan theta to both the triangles. Let me first apply tan theta to the smaller triangle with the angle as 60 degree. Tan is again opposite by adjacent. What is the opposite side? For 60 degree angle, the opposite side is DF, which is 28.5, by the adjacent side is Y. This is the adjacent side, which I represented it as Y. Tan 60 value is root 3. So the value of Y is 28.5 by root 3. Let us rationalize the denominator so that we remove root from the denominator. Root 3 into root 3 is 3. 3 9s are 27, 1 is remaining, so 3 5s are 15. Value of Y is 9.5 root 3. We actually wanted to find out the value of x. We wanted to find out how much distance the boy walked from the point B to point E. Okay, so let us apply tan to the angle, to 30-degree angle. Again, tan theta is opposite by adjacent. What is the opposite side for this angle, 30-degree angle? It is 28.5. That's the opposite side. And what is the adjacent side? See, for this bigger triangle, the adjacent side is this BF. So the adjacent side completely is x plus y, because from here to here it is x and from here to here it is y. So the adjacent side is x plus y. Tan 30 is 1 by root 3. 1 by root 3 is equal to 28.5 by x plus y. 1 by root 3 is, okay, let me just cross multiply this thing. So I'm just cross multiplying this thing here. X plus y into 1 is x plus y is equal to 28.5 root 3. Value of y, we know that it is 9.5 root 3. So in place of y, I'll just substitute 9.5 root 3. X is equal to 28.5 root 3 plus 9.5 root 3. If I take it to the right hand side, it becomes minus 9.5 root 3. (28.5 minus 9.5). That should be 19 root 3. So the distance that he walked is 19 root 3 meters. Let us go ahead and work on the third problem now. If you know how to draw a relevant diagram after reading the question, it pretty much means that half of the job is done. So let us first concentrate on drawing a relevant diagram for this question number 3. It says a statue stands on the top of a 2 meter tall pedestal. Okay. So let us say this is a pedestal, and on the top of this pedestal there is a statue that is standing here. So this is our statue, this one right here. So that is our statue. From a point on the ground, the angle of elevation of the top of the statue is 60 degree. Let us say from this point on the ground, the angle of elevation to the top of the statue, don't forget this is our statue, right? So the angle of elevation from this point to the top of the statue is how much? 60 degrees. And from the same point, the angle of elevation of the top of the pedestal is 45 degrees. See, this is our pedestal, right? This is our pedestal, and this point here is the top of the pedestal. So this guy is looking at the top of the pedestal, which means this, from the same point, and he now gets an angle 45 degrees if he looks at the top of the pedestal. Find the height of the statue. So I have to find out the height of the statue. This is our statue, so I have to find out this height here. Okay, let us denote, let's just write down vertices for these triangles A, B, C, D. So I have to find out the value of CD. I don't know the length of CD. Let me just denote it by the letter H. So I have to find out the height of the statue. CD is my statue, okay, and BC is my pedestal. Okay, let me just denote BC by X, and let me just denote AB by Y. I have to find out the value of H. Now we have again two right angle triangles. One is ABC. Let me just use a color here, a different color for two different triangles, so that you can distinguish pretty easy. So this is one of our right angle triangle ABC. So ABC is one of our right angle triangle, and let me draw using a different color here the second triangle, this bigger one, A B D. This bigger one is our second right angle triangle, right? Okay, so I'll apply tan to this angle first, 45-degree angle. Tan is again opposite side by adjacent side. What is the opposite side here? Okay, tan 45 is 1, opposite side for 45-degree angle is x, adjacent side is y. So value of x is equal to y. Y it gets multiplied here, y ones are y, so value of x is y. Now let me go ahead and apply tan to the other angle, 60 degrees. Tan 60 degree is equal to, again tan is opposite side by adjacent side. Tan 60 is √3. What is the opposite side for this angle, 60-degree angle? For 60-degree angle, the opposite side is BD. So from here to here I have the value as x, and from here to here it is h. So completely the opposite side is x plus h. And what's the adjacent side? Adjacent side is y. √3y is equal to x plus h. Value of x is √3y minus h. No, one second, what are we dealing with? Okay, let me just do it this way. We know that y is equal to x, so in place of y I'm just substituting x. Okay, so in place of y I'm just substituting x. X is equal to x plus h. Oh, okay. A statue stands on a 2-meter tall pedestal, so the height of the pedestal is already given as 2. Oh my goodness. So let me take this value as 2. I was taking it as x always. I'll just take it as 2 now. Now that we know the value of the height of the pedestal, it's already given in the question. The height of the pedestal is 2. I believe I just overlooked that. So the value of x is 2 here. I was taking the height of pedestal as x, but I now know that I cross-checked and see that the height of the pedestal is given as 2. So the value of y is 2, right? Let me just write this thing fairly here on the left hand side. √3 is equal to 2 plus h by y. Y is equal to 2 plus h by √3. Value of I have to find out the value of y, value of h, right? So in place of y I'll just substitute 2 because I know that it is 2. 2 into √3 is 2 √3 is equal to 2 plus h. H should be 2 √3 minus 2 plus 2. If I take to the left hand side it becomes minus 2. So h is, if I take 2 common, I'll get this as √3 minus 1. Value of √3 is 1.732. Okay. 1.732 minus 1 would be 0.732. 2 into 0.732 should give you the answer. So the height of height of the statue is 1.464 meters. So this is what happens when we overlook things. So it's clearly given in the very first sentence that the height of the pedestal is 2 meters, but I overlooked that, and that became a little bit problematic. No issues. Let us move on to the next problem. Problem number 4. From the top of a building, the angle of elevation of the top of a cell tower is 60 degrees. From the top of a building, the angle of elevation of the top of a cell tower is 60 degrees. Okay, so we have a building here. Let us say this is our building. Oh my goodness. Let me draw it once again. So this is our building, and then we have a cell tower. Let us say CD is our cell tower. Now if we look from the top of the building to the top of the tower, so this is my building, okay, and this is our tower. If we look from the top of the building to the top of the tower, the angle of elevation that we get is 60 degrees, and the angle of depression to its foot is 45 degrees. And if we look at the bottom of the tower, the angle of depression that we get here is 45 degrees. If the distance of the building from the tower is 7 meters, then find the height of the tower. Now it is saying that the distance of the building, this building, from the tower, the distance between the building and the tower is 7 meters. Now if you carefully notice this diagram right here, A, B, E, C, it looks like a rectangle. So if AC is 7 meters, then BE also should be 7 meters, because opposite sides should be equal in a rectangle, right? Now we have two right angle triangles. Again, BDE is one right angle triangle, and then BEC is the another right angle triangle. And what do we need to find out? We need to find out the height of the tower, and this is the height of the tower. From C to E, let me just take this height as H1, or else let me just take this as X. CE I'm taking it as X, DE I'm taking it as Y. Okay. Let me apply tan theta. Tan 60 degree should be opposite side by adjacent side. Oh my goodness. Handwriting is becoming messy. Tan 60 is √3. Opposite side for 60 degree angle is DE, which is Y. I have represented that by Y, by the letter Y. And the adjacent side is BE, which is 7. So Y is equal to 7 √3. So this is what I get when I apply tan theta, tan to 60 degree angle. Now I'm applying tan to 45 degree angle. Again, tan is opposite side by adjacent side, right? Opposite by adjacent. Tan 45 is 1. What is the side opposite to 45 degree angle? It is CE, which means it is X. I have represented CE by the letter X. X by the adjacent side, again it is BE, which is 7. So the value of X is 7. Now the height of the tower should be this complete thing. From here to here we have X, and then from here to here we have Y. So X plus Y is the height of the tower. Height of the tower is X plus Y. Value of X is 7 and value of Y is 7 √3. You can take one common, you'll get it like this. You can keep it like this also, or you can simplify it a bit further. Value of √3 is 1.732. 1 plus 1.732 is 2.732. I'll multiply 2.732 by 7. So the answer should be 16.604 meters. So that is the height of the tower. Okay, let's move on to the next one here. I believe fifth one I can skip it. You can try it on your own. We'll go ahead and do the sixth one. The angle of elevation of the top of a building from the foot of a tower is 30 degree, and the angle of elevation of the top of the tower from the foot of the building is 60 degree. If the height is 30 meters high, if the tower is 30 meter high, find the height of the building. Okay, let's do this. The angle of elevation of the top of a building from the foot of the tower is 30 degree. Let's say this is the building and this is the tower. The angle of elevation of the top of a building from the foot of the tower is 30 degrees. So this is my tower and this is my building, right? Let me represent building as AB and then I'm representing tower as CD. The angle of elevation of the top of a building from the foot of the tower. From the foot of the tower, if we look at the top of the building, the angle of elevation that we get is 30 degrees. And the angle of elevation of the top of the tower from the foot of the building, if we look from the foot of the building to the top of the tower, this is the top of the tower. If we look at the top of the tower, the angle of elevation that we get is 60 degree. If the tower is 30 meters high, so if the height of the tower is 30 meters, find the height of the building. We'll have to find out the height of the building, which is AB. Let me denote this by the letter H. Height of the building, I'm representing it by the letter H. And the distance between the building and the tower, I'm representing that by the letter X. Take care. Okay, so we have to find out the height of the building. We have to find out the value of H. Again, we have two right angle triangles here. One is ABC and then the other right angle triangle that we see is ACD. We just have to apply tan theta to both the right angle triangles. That is it, as simple as that. So I'm applying tan to 60 degree angle first. Tan 60, tan is again opposite by adjacent. Opposite is 30 here, adjacent is X. Tan 60 is root 3. Root 3 is 30 by X. So X should be equal to 30 by root 3, right? Again, we just have to rationalize the denominator so that we can remove the root from the denominator. 30 root 3 by root 3 into root 3 is 3. 3 tens are 30. So value of X is 10 root 3. Now let us go ahead and apply tan to the other triangle, which is ABC. Tan 30 degree should be again opposite by adjacent. Adjacent side is X. Value of tan 30 is 1 by root 3. H by X. Let me just cross multiply. X is equal to H root 3. So this is my first equation. This is my second equation. From 1 and 2, we see that the left hand side is equal. So we can equate the right hand side. I'll just use this space. H root 3 is equal to 10 root 3. H is equal to 10 root 3. Why does it do it like this? Root 3 is multiplying on the left hand side, so root 3 will divide on the right hand side. Root 3 gets cancelled. I get the height as 10 meters, right? So the height of the building is 10 meters. As simple as that. Okay. Two poles of equal heights are standing. Okay, I believe I can just skip the 7th one, the 8th one, because yeah, the 8th one is also almost the same. I can just skip it. If you guys find any issues in solving 7th and 8th questions, you can just notify me in comments. I'll go ahead and solve the 9th question for you now. Let me quickly take a new worksheet here. Okay, the angle of elevation of a jet plane from a point on the ground is 60 degrees. After a flight of 15 seconds, the angle of elevation changes to 30 degrees. If the jet plane is flying at a constant height of 1500 root 3 meter, find the speed of the jet plane. Okay, simple. Let's just do it this way. Let us say that this is our jet plane. Okay, and I'm looking from this point. The angle of elevation that I get is 60 degrees. And this plane is at a height of 1500 root 3 meters. This plane is at a height of 1500 root 3 meters. Now again, this after a flight of 15 seconds, let's say this jet plane flew for about 15 seconds in this direction. Now after it flew for 15 seconds, if we now see the plane, we get the angle of elevation as 30 degrees, right? So we have to find out the speed of the jet plane. Okay, I'll just complete this diagram like this. So we again have two right angle triangles. Let me just name this as A, B, C, D, E. Okay. So first the plane was at point E. First, when the angle was 60 degrees, when the angle of elevation was 60 degrees, the plane was at point E, right? This point. So I have one right angle triangle here, A, B, E. This is one right angle triangle. Second time, after it flew for 15 seconds, it went to the point D. The jet plane went to the point D. Now I have an angle of elevation as 30 degree. So I have this as a right angle triangle. ACD is the other right angle triangle that I see here, ACD. If BE is 1500 root 3, then CD also should be 1500 root 3, right? Because BCDE, it looks like a rectangle, obviously. So this also should be 15. The opposite side should be equal. What else? Let me take this as X, AB as X, and let me take BC as Y. Am I missing any other information? No, I believe that is it. So I'll first apply tan to 60 degrees. When the angle was 60 degrees, the jet plane was at the point E. So this is my right angle triangle ABE. Okay. So tan is again opposite side by adjacent side. Opposite side is BE, which is 1500 root 3. Or let me just do it this way: opposite side by adjacent side, right? Tan is root 3. Tan 60 degrees is root 3. BE is 1500 root 3 by AB. I don't know. I'm just marking it as X for now. If I just multiply X to the left hand side, X into root 3 will be root 3X. Root 3 is multiplying on the left hand side, so root 3 will divide on the right hand side. So the value of X is how much? 1500. I'm actually interested in finding the value of Y, because I have to find out with what speed, what was the speed of the jet plane. The jet plane, it flew from point E to point D in 15 seconds, and I need to find out how much distance it covered. The distance, I have to find out the distance between ED, which is same as BC, right? So I am more interested in finding the value of y. Let me apply tan to 30-degree angle. Tan is again opposite side by adjacent side. So for this bigger rectangle, bigger right angle triangle, the adjacent side is x plus y, right? X plus y. Tan 30 is 1 by root 3. X value, I know that it is 1500, so I'm substituting it as 1500, plus y I don't know, I'm writing it as it is. Let's just cross multiply. 1500 plus y is equal to 1500 root 3 into root 3. Root 3 is dividing, so root 3 will multiply, right? I'm just cross multiplying this like this. 1500 plus y is equal to 1500 into root 3 into root 3 is root 9, right? 3 3 is a 9. Root 9 is again 3. 1500 plus y is equal to 4500. 1500 into 3 is 4500. Y is 4500 minus 1500, which is 3000. So the distance that it covered in 15 seconds is 3000 meters. Jet plane was at point E. After 15 seconds it reached the point D, and it covered a distance of 3000 meters in 15 seconds. I'll have to find out the speed with which the jet plane traveled. We know that distance is equal to speed into time, right? So speed will be, I'm not sure why this tablet is acting up. Okay, so speed should be distance, oh my god, no, speed should be distance by time, right? Distance is speed into time, so speed will be distance by time. The distance that it covered is 3000 meters, and the time it took is 15 seconds, right? It covered a distance of 3000 meters in 15 seconds. 15 ones are 15, 15 twos are 30, right? So the speed of the jet plane was 200 meters per second. I believe this is it. The last problem, 10th problem, I believe you can just write on your own. If you have any questions, you can just write it as comments on the video. So with this we have completed chapter 12, applications of trigonometry, from Telangana state syllabus. Take it until next time. Goodbye.